Welcome to Web Handling. My name is Dave Roisum. In this continuing series on two-drum winders, we discuss 5 exceedingly difficult drives. The two-drum winder is easily the most challenging of motor control situations found in the pulp and paper complex. In fact, the two-drum winder has among the most challenging drives of any force control motors found in any industry. If that were not enough, the paper mill is among the most unforgiving because downtime costs can exceed $20,000 an hour. Beginning with the Unwind, we find a motor stretched to the limits of range. Speed ranges exceed 100 to 1, while RPM and connected inertia ranges are 10 times that. To this we add a dozen modes of operation the drive must perform, some of which are totally unique to the Unwind. In addition to forward and reverse directions and torques, most Unwinds are able to regenerate power back to the lines. However, the web handling challenges are even greater in that precise tension must be maintained during acceleration, run, and deceleration. Finally, the drive must perform well at or near zero speed. The guide roll drive is, above all else, a helper drive. From Module 6 of Web 101, we learned that a well-tuned helper drive will make bearing drag and inertia effectively disappear as far as the web is concerned. What we mean by this is that the drive's task is to make sure that there is no change in tension on the web as it goes over that position. To this we add one very unique and poorly known twist. That is, the typically big and slippery roller will entrain enough air on high-speed winders to lift the sheet completely off the roll. These mechanics were covered in Module 3 of Web 101. In fact, we can calculate the liftoff speed via the methods given in my roller book, or more conveniently, the Abbott app called Air Lubrication Calculator. However, the challenge is not so much during liftoff. The bigger challenge, much like flying, is landing. If the drive is not precisely tuned, there will be a slight speed mismatch. This may cause a huge tension spike because of the inertia of this very large and heavy steel roller as it grabs onto a lightweight paper web. The bowed roller drive is also a helper drive, and as such, we demand that the well-tuned drive not tug in either direction on the web. However, here we have a slightly different concern. From Module 9 of Web 101, we learned that a reduction of traction capacity means a reduction in spreading capacity. We also learned that exceeding the traction capacity would not only disable the spreader, it would likely cause it to misbehave. As with any helper drive, the motor is in torque control. However, the torque versus speed curve is tuned by matching speed even though speeds are not what is being controlled. A further nuisance is that the drive may need to be retuned after the first day and then a few weeks later as the bearings and cover break in. If your drive people do not have a rock-solid understanding of all of what we just outlined, they need to go to school. The front drum drive control mode is unique to the two-drum winder, the center surface winder, and the dual drive laminator. That is, the motor is in torque split control as opposed to mere torque control, as we just discussed. Here, the rear drum drive maintains speed by supplying whatever plus or minus power that is necessary. However, the front drum looks at the total power consumed and sets its effort at a set point fraction of that, which could be more or less, or more usefully, positive or negative. Though the general effects of roll tightening and loosening are well understood, as we covered in Module 25 of Web 101, the detailed mechanics are poorly studied. We will close with 2 avoidable drive handicaps. The first is a chronic undersizing of the motors. Because motors are expensive and the benefits of torque split are poorly understood, there is a tendency to undersize or greatly undersize the motors. The practical effect of this is that you can often redline the motors in the direction of tightening or loosening as the roll defects indicate, with fewer risks than pegging the tension or nip knobs. The main risk, besides getting the roll tighter or looser than desirable, is drum slippage. Here we have an avoidable control sin that has been part of the drive culture far too long. That is, that slippage is easily knowable by the drive and must be reported just as we expect tire slippage to be reported by our car. Finally, we are now better positioned to understand the rider roll drives and what they may or may not do for winding. First, most are set up as helper drives. However, they could potentially be used for controlling tightness, except that they are way, way, way too small. In fact, they are so small compared to the drums that it is doubtful whether they could make any practical difference whatsoever in the wind-up system. In fact, this doubt is well reinforced by uncountable cases where the drive was broken for months and no one knew, and no one could detect any difference when it was repaired. The drive could get broken in any one of 3 different ways that are epidemic on big winders. The motor could become disabled, the drive belts could get loose or broken, and finally, the couplings between segments can get broken. In fact, these couplings snap like popcorn because the tiniest diameter difference on the winding set causes a huge torque difference on the segments. I hope I have made a convincing case for the earlier statement that the 2-drum winder drives are among the most challenging of any motors in any industry. Those of you in the paper industry know all too well that stuff is too expensive to learn on the job. So if any of this is not rock solid familiar to you, it may be a good idea to go to school. Both myself and Clarence Clausen have 2-day schools on the mechanical and control aspects of winders and winder drives respectively. These are offered in plant, in the classroom, and online through AIMCAL. Thank you so very much for watching this module in my Plant Practical series. Stay tuned for more winder and web handling topics.